Okay, this is video 3 on the 3D printed battery operated version of the Devil Girl from Mars' robot, which I guess is pronounced Chani. And I'm going to show the first one we showed stills from the movie so you can see what it looked like when it was used in the movie, and the second one we showed the mechanical walking part of the build, and this one we're going to talk about the body and the dome mostly, and the lighting effect in the head. In this particular case, there's actually two different ways we can do the dome, and this one is a 3D printed dome piece, and you can see there are lights in there, and this can be printed in vase mode using a STL file that I provide, and of course this could be made clearer. You could sand this and then clear coat it and it would become a lot more transparent if that's what you're after. A lot of the images in the movie, though, it doesn't look transparent. And this one is a thermal formed one, which of course is very transparent. And in the case of that one, you could actually take some 400 grit sandpaper and scuff it up and fog it over a little bit if you wanted to, if you didn't want the really clear look. As I said, this one is just 3D printed in this form. Actually, when you're in vase mode, your bottom has to be solid, so the top becomes the bottom on your printer. And you just select the file that I have there, and in your slicer you have to select vase mode. And you'll be good to go, no supports required. Now, in order to do the thermal formed one, I've done this process before in video. I'm moving the camera, so hold on. Let's get you all spun around here. I did a project a year or so ago on the GE walking robot, and had to thermoform a large canopy dome for it. So this can be the same process, where it just takes some scrap plastic off a blister pack, anything you might buy, like you buy a bunch of batteries from Costco or a pair of scissors or whatever. They're always going to have a hard plastic blister pack top. Just cut that off and use that plastic. Took some scrap wood. This is larger than life, obviously, because you know how small the little dome is. It's actually, thimble size. And I had a piece of 1/2 inch plywood laying out there, so I took a hole saw. Didn't have to be round, could have been square, could have been triangular, could have been cut by hand. Doesn't make any difference, just needs to be bigger than the part you're going to do. Anyway, I had a hole saw, so I cut that, and then I cut a smaller one from that piece of junk that came out of the middle, and I screwed this piece, which you 3D print, to this block of wood, and then this ring part here is going to be pushed down over the top of this when the plastic gets hot. All these little screws I used to screw that piece of junk plastic to this, and I used the toaster oven in the kitchen, set it about 250 degrees, preheat it. You don't want it coming up to temp with the plastic in there because you'll blister the plastic. Preheat the oven, then put the plastic in. Actually set this up off the wire grate in the stove on some blocks of wood. They sell them as 2x2s, but it's actually 1.5 inch square. I just had some little chunks of that sitting there. Could have been anything. Could have been a couple of bowls. If you don't have screws, you can use clips. Like when I did GE one, I just used some clips, and I think I had a much thinner, like 1/8 inch piece of wood. And this is just showing you the parts. Oh, I should mention the head is narrower in the front and the back than it is on the side. It'd be easier to see that on the 3D printed one here. So you can see this little area here is narrower than the sides. So that's why I had an arrow marked on this part and an arrow marked on that part. So when I went to shove this part down over the top of that to stretch the plastic around, it would be in the right place. So in this case, let's zoom up here. Here we can actually see, had the plastic and the wood sitting in there, got it hot, threw this down, and then grabbed that ring and just shoved it down, and it stretches the plastic over the part that you 3D print. And then you should be able to pull the ring off after a minute or so. The plastic will cool enough that it won't move anymore. and then remove all the screws and take it from that, and you end up with this. And then just take a pair of scissors and trim around the part, and you'll end up with a part that looks like this, which fits right down into the grooved top that I provided in the body design. Now obviously the 3D printed one is easier to do because it just requires a printer, and you already have the printer if you're making the project. And if you wanted it clearer, that'd be fine. But this actually looks a lot like the way the robot looked in the movie. Now for the lighting effect, I had from the dollar store, and you can still buy them in craft stores. You can buy them anywhere you want online. They normally call them fairy lights or pixie lights, but it's these little teeny LEDs on a long strand of wire, usually like 10 of them, and a little battery holder. And like I say, you used to be able to get it for $1 at the dollar store, but even if you have to pay $3 or $4 at a hobby store for them, that's fine. But the LEDs are spaced about this far apart in real life, and there's 10 of them. So in this case, you had to double up all the wires, push the LEDs close together, and just wrap the wire around them. And because the wire got rather thick, I actually drilled the holes out here just a little bit bigger and shoved them down in there and soldered onto the end of them. Now, I added a current limiting resistor because I'm running on 4.5 volts, so I used a 220 ohm resistor to limit the amount of current going to the LEDs so they wouldn't add too much draw to the batteries. I don't want to lose all my power just to the lighting effect. I really meant for this to be facing forward. This is the back of the robot because there's the ducktail. But when I put them on and wired them and soldered them in, I had them the other way around. It was a little late to change. I'm going to move you back to where we were to begin with. Over here somewhere. Okay. I guess we're somewhat in the same area, right? There we go. So the body prints as one piece vertically on your printer as you see it sitting, not with the arms. The arms are separate this way. And I used the tree supports. I'm going automatic mode, add tree supports, and basically it just adds some supports under this ledge part here. It adds some supports under the flat part there. It had one little tree limb that grew up into the armpit, and then of course it runs tree supports up into the inside of the body to support this upper area where the holes are. So other than that, it just prints as one piece, and the tree supports pop out really easy. Now the arms, as you can see, I split a seam right along there. So there is a front and a back to the arm, and it's the same arm on both sides, so it's just one file. You just print it twice, glue them together, and there's a place where they push into the body. Purposely made the pin that pushes in extra long, sticks into the body, because when you shove this part up in there, it needs to hit something so that it trying to see if I'm staying on camera and doing this without breaking anything. There we go. So now you can take maybe I should turn that light on the camera again. Let's try that, see if it helps. And come on, light. There we go. So now you can see down in there. You know, I covered the mechanics and the switch and everything on the last video, but you're going to need some needle nose to hold the switch down in there as you screw it in place, and I needed needle nose to shove the two light wires up and out the holes, and actually soldered the LEDs on out here and then stuffed them back in again. And once I knew everything was working, I actually dripped some super glue down there to secure this to the top of the body, so if it ever got tugged on, it wouldn't be breaking the wires off the switch or breaking the wires off of the LED lights. But you can also see the pins on the arms, how they protrude a little bit on the inside. And there's plenty of room for the wires to just go wherever they want to go when you shove everything back down into place. Like so. Can't go too far. It's going to go to the right place and stop. And there you have it. Your Chani robot, Devil Girl from Mars, with 2 different head options. 3D printed one, and then we've got thermal formed version. Files will be up on Thingiverse, hopefully. I've been having some troubles with that recently, but hopefully I have figured out what's going on, and we'll see if it gets resolved.